Welcome to a new test and teardown video. This time it's another Heathkit, and this one is the IG-72 audio generator. It's from about 1960, and this one was, of course, sold as a kit, so it's always a little bit interesting to see the build quality and how is everything inside, because some builders, they got super good skills and some not so much. I kind of like the layout here, and everything is neatly explained. There is no variable frequency on this one, like a potentiometer like we are used to, but it's all switches. So look at that one. This is cycles, so that means every little click here is 1 hertz. And here, every click is 10 hertz. And then you have your multiplier up here, where you multiply everything by 10 or 100 or 1,000 and so on, right? And then there is this output attenuator and variable output. I also got printed schematics, not the best quality copy, but at least I got all the nice manual and layout here and where is this and that and all that. And yes, well, that one is a little bit interesting. So there's supposed to be a bulb in here, and in my little package there is another little bulb, but this one is a 10 volt. So this one is only for the power on indicator. I bet there is a little bulb up here, but I think I want to open and inspect, and that is normally super easy. Let's first look a little bit at the schematic. It's fairly simple. In the upper right, we got the transformer and a rectifier tube, and then of course the classic filter section with capacitor and inductors, and then the analog supply is quite nice and stable and ripple free. The oscillator consists of 2 tubes, a 6CL6 and a 6AU6, and then there is, of course, the lamp in the feedback system that will ensure exactly the same amplitude at all frequencies. And in the bottom left, we see a oscillator set frequency system. This is some capacitors and some resistors here drawn on the schematic just like that. But in reality, it's, of course, all the resistors and capacitors on all the switches. So now we can look inside this unit, and we see the output attenuator is right here. That will be the 1 hertz step and the 10 hertz step. That's done using resistors like this. It's quite funny to see those are just the old carbon resistors. Of course, this unit is from about 1960. Chassis is a ground, and there is not a lot really in here. Of course, the schematic is also fairly simple. So here we got the diodes for the meter, and that will be the filament bulb for the feedback loop. And if you look real careful, the filament seems to be intact, and that is essential. Otherwise this, then I wouldn't be able to fix this at the moment. So that's, of course, the rectifier tube and the big double capacitor, and that will be the inductor for the filter. I had to glue this capacitor because you can see it's hanging here on the loop from this bulb and all the way to the oscillator, and it was just hanging and dangling around. And this one here is also a problem, so I probably also want to glue that one. Because you can't have all those components moving around. And this is a classic Heathkit thing. Look at it, this flimsy. I mean, also the case is very, very thin and very, very lightweight. And that is, of course, a thing to keep cost down. But it's also making everything here a little bit, see how flimsy it is. And when things can move, you will have all sorts of instability and such. Also, I was gluing a few of those knobs because they were cracked. And when I tried to tighten the screws to make the knob point at this correct position, it was just going all the way around and I couldn't fix it. So yeah, I had to put in a little drop of 2 component, so that's why we have it here. And we can have a little look inside here. That will be the multiplier. So the multiplier, that is the capacitor section of the oscillator. And that is how it looks. There is not a lot in this one, and it is pretty well done. Oh yeah, look at that. How much it's bending. So that little bulb here is the power on indicator. Let's see if that works. And then I slowly crank up the mains and monitor the current consumption just for a safety. So this is 100 volts and it's using 6 watts. So that is perfectly fine. I feel I can easily continue. 150, 60, 70. Okay, so let's just go to 220. Like that. It is, I will go to 230. That is the normal voltage at the moment. And here we go. See, it's getting warm up. And that is the amplitude. Let's see if there is a sine wave in. Ooh, it's clipping. Why are you looking like that? Am I driving it? No. It is clipping real bad. And so let's focus a little bit on the frequency. See, this is 5 and 50. 5 times 10, so it's 500 and so it's 550, right? And here on my scope I can see it is 529. So that is quite all right. But that sine wave there is really, really bad. And the fun thing is, it is not. Oh yes, it is. It is a little bit. No, not really. Well, I think I will try and see if there's any good explanations in the manual about this right there. I think I maybe already figured this out. So look at this switch here and look at this. No block with focus at the moment. Why are you doing this to me? No change whatsoever. So this means this load thingy is maybe why we see this. What do you think about this? I already solved it. It turns out about the calibrations here. This is the front panel output, right? Variable output. That potentiometer here is for the meter. And then that one is for the drive into this oscillator loop. So if you crank this up too much, you oversteer this feedback loop, and that causes it to clip. So I just adjusted this little oscillator feedback level there, and I added, of course, a little bit of instructions for the future. So now it's fantastic. By the way, when you zoom out like I just did here, 50 milliseconds per division, you can see we got a perfect straight line, and that's because it's completely ripple free. Wow, lucky. Of course we need to show the crazy extremes. This is 0 and times 1, and then that will be 5 cycles. Look at the meter here. And here we go. 4.9 hertz. What happens if I try and go even further? Oh, then maybe it will. It can really make super low frequencies. It's amazing. I did not expect it to be able to work that low. But of course it's not going to work at 0, right? So this 2 hertz sine wave. Really? I think that is actually all I wanted to show about this unit. There's not a lot more to talk about. So thank you very much for watching. See you around. Bye bye.